So in dogfooding the product and also in talking with customers, we find that people haven't really incorporated analytics into the daily routine. And I think the reason for this is because we just don't have the time, and learning these proprietary interfaces are a hassle. So what we've gone and done instead is we've based on open source, powerful open source technologies. So to name a few, Stenographer, right? Good old Lucene, Elasticsearch, Kibana, right? So we ask that you spend the time to train yourself in these technologies, right? Not a big ask. I mean, really powerful technologies, just like learning Ansible, right? And out of necessity, I mean, a very small team in Big Switch Networks. So I have the distinct pleasure of representing a very small team in Big Switch Networks to show you the demo we're about to see. So this is ordinarily a 1 hour demo that we do for customers that frequently run 2 hours. So this is going to be really abbreviated. There's a lot of information in there. I hope everybody in the room can read this. So this is our S-Flow, our dashboard on S-Flow, essentially. Right across here on the second row are the typical 4-tuple. But above here are some interesting bits of information that we present, right? So the biggest flows, not by their IP and layer 4 ports, but decorated, right? So host names popped in. You'll see rich contextual content like which AS number, right? The flows went through. Same treatment here, right? The source, so source groups. So you'll see here what's interesting is that we have the public AS labels as well as internal labels. So they're mixed into the one space. So source groups, desk groups. So I mentioned Lucene. One would expect being able to search. So sure enough, we can search away. So a search for Amazon brings up all flows going towards Amazon, right? Internally, based off L4 labels, search for NFS brings up all NFS flows. And of course, you can search by IP address just as well. So I could clear that away. So down here in the traditional 4-tuple, you see IP addresses, you see host names, DNS names being popped in. You'll see it's configurable labels for all the L4 port numbers. Right. Down here, we've broken down the different categories of traffic by RFC 1918. A big switch special is, we can tell you which part of the BMF network the flow was picked up on, right? So these are these slices here. And then through LLDP, CDP, UDLD backpropagation, we can tell you what point of the production network those flows came in on, right? So you see how this sets up the ability for one to do hop-by-hop debugging, right? So you expect a flow being seen at 4 points, and it's not being seen at a 4th point. Now you have a pointer to the point of your production network that needs investigating. Something fancy here, but this is stock Kibana. If I wanted to see all flows going to Japan, right? That's just a filter like that. And now I have only flows going towards Japan. And sure enough, KDDI, right? That makes sense.
Can you go through how we would find outliers?
So yeah, really good question. So that's a good segue into my next demo, outliers. So the setup for this part of the demo is last Friday. We saw a whole bunch of emails coming in. People were able to get on OpenVPN, right? Leading up into right throughout Friday night into Saturday morning, right? So speaking of outliers, I came into the office and I looked at this graph, right? So right away, this is the time that we were talking about, right? So that's clearly odd, right? So the peaks here correspond to basically our weekdays, right? Our weekday traffic buildup crescendoing at noon, right? So this is what we were looking at, right? I'll go through the debugging scenario, how I fixed the OpenVPN issue. This being a Saturday, this didn't exactly make me a hero, turning the lights back on a nice July weekend. So what I did was, coming into the office, I just selected over the point of the anomaly, right? So that gives me a time filter just in that area that I'm interested in. I come back to the top flows. I see my problem here, right? So I've got 3850, which is our internet uplink, talking out to 190 to 168, right? So now the question is, which internal host was it that was producing traffic to us 190 to 168, right? So I worked my way down the list, and so down here, do you see it? I mean, okay. Yeah, dense information. I'm not even spotting it. So 190 to 168. So we see the counterparty, right? 3061, and that's a QA host. So immediately what we then did was we went to BCF CLI, listed for all endpoints that had that IP address, right? We found the endpoint that it belonged to and promptly did a shutdown, right? So that's exactly the tail end of my time selection, right? So we stopped spamming our internet uplink, and lights were back on.
So we already kind of categorize into this cross versus external, like east-west versus. Can't hear you. So this categorization really helps us. Like, you know what is your expected. Good. Sorry. Your east-west versus north-south traffic. So that automatically happens. You don't have to. These things are going to automatically tag because we know the private versus public subnets and so on and so forth. So now looking at that, once you have that information, it's easier to kind of see the trends and see the ratio. The ratio of typically east to west versus north to south, what we expect and what was there was pretty different, and that's why we could. It was easy to kind of.
So the map visualization is good and it can help in troubleshooting, but then what do you do if all your traffic is more internal RFC 9019 space?
Yeah.
Is there a way to classify what range belongs to what location?
Yes.
Yeah, we saw that up above where they said QA. QA is a range of IP addresses that's QA.
So you can
So you
custom
can create
tag.
your own.
You can custom tag any subnets. And if you are using BCF for production network, we automatically pull that information. This tenant VPC has what subnets,
Right.
and from there we.
But being in a VPC is actually an advantage then because
Yes.
you're tagging by VPC. You're
Yeah.
classifying.
And we already fetch that information from the BCF controller and populate it over here.
Yeah.
Especially because probably the filter is going to be the filter that you will be able to use as a concatenation between the VPC tag and the IP, because
Yes.
1918 it can be reused, right?
Yes. Yeah. So you can use that. You can use the VPC name and segment name and so on and so forth.
So our tagging is flexible, right? So we have ASN labels. This could be VPC names we get from BCF or our production fabric, right? Whatever. It's flexible tagging like you see on Amazon.
So everything gets merged in, like the private versus the public tagging.
Now, what you just showed here was good because we had visual data, but the analysis looked pretty manual. Like, I mean, we're looking at this, but this looked like a pretty
It's an alert
significant
counterpart.
anomaly. Like,
Yeah.
you're doing anomaly detection like this host. It'd be great if you just got like, hey, this host is operating at a 200% of normal. Like,
So you can alert. You can set the thresholds, and you can set the alerts. Hey, if I see my the ratio of north-south traffic to east-west traffic going beyond certain number, send me an email and tell me who is contributing to that. You will automatically get an alert.
So-
You don't have to go and do post-mortem debugging. You will get alerted.
okay. So, and thresholds are great.
Yeah.
Until you have like 800 of them that you have to set manually. So, like, how much intelligence is built into helping me determine those automatically?
Automatically, yeah. So that's where exactly you got the point. So the way it works is the journey is you start post-mortem, then you do alerting, and then you do predictive, like machine learning based.
Yep.
Yeah. So yes, that's what we are working on right now. How do you auto baseline things, and how do you you don't need to even set me this. I mean, you learn what is the seasonality, what is all those kind of things, and we are working on those models right now as we speak.
Okay, so that's a work in progress, but that's the direction you're headed.
Yes.
Okay.
We're looking at products that are 6 months out.
I keep asking that question. Yeah.
That's
so-
the evolution, correct? So
Yeah.
you start from alert. And, yeah. So we are going through the evolution of that.
Yeah. Okay. Very good.
So can you step through using this for application dependency mapping? If you drill down on, say, top destinations, do you have any type of chords that would show what's talking to what?
So we have all the information showing flows as they go through the multiple hops in an application dependency map. We are working on the rich visualizations to show us actually, the graph presentation of it, right? So the 3 tiers. So we have all the we have all the information.
Yeah.
The visualization is coming in sequence.
Excellent.
Or you can just click on Jenkins and you'll see who all is talking to Jenkins.
Yeah. So I mean, at a simple level, in this pie presentation. So if you wanted to answer the question, who was talking to? Okay, I see Jenkins over here, right? So that's the destination. We can at least see the counterparties talking to Jenkins.
All these guys are
Okay.
talking to Jenkins. So we can get this, okay, who is talking to whom kind of
Yeah.
mapping. Yeah.
And then using what layer for protocols?
Yeah.
Okay.
So this is as much a security use case as it is network analytics.
Yes.
I
It's
think so.
really-
Yeah, when we started out with this product, we really didn't have the mindset that we were going to do NPM alone. So really, we didn't know where the boundaries were. So we felt the creative license to go wherever it takes us.
Can I continue to drill down into those flows?
Yes. Yes. You can keep going. So this is just the first. And
Yeah. So every one of these graphical elements, they're all interactive. So I just click on that. I just clicked on that flow, and I'm filtered down just to that one flow. Right. So you see the four tuple is now just
No.
one going right across.
And where do you see those 4 tuples in the production network?
Yeah.
So it's important to correlate all these things back to the production network because you want to know where things are happening in the production network. Yeah.
Yeah. The pie slices are all clickable. Right.
I like the dark mode.
Yeah.
Yeah.
Sorry.
I just want to make that, the comment I made it on Twitter, but the interfaces that you guys have are really, I see these products so often and the interface is just kind of bolted on. It's just something that's thought about after the fact. I really like your interfaces. There's something I'd want to work in.
They're intuitive, they're
Yeah.
functional, they're to the point.
Yeah.
And the cool thing is, this is stock Kibana. So
Yeah.
you're learning a Swiss Army knife.
Yeah.
Just Kibana.
Sometimes we're afraid of talking about GUIs and interfaces because we think that we might be seen as someone who privileges
GUIs?
aesthetics to functionality, but this is both, I think. And the dark mode, if you work long hours on these interfaces, I think that quite a few people have Chrome plugins to go dark mode, but this is built in. It's cool.
Like you said, it's Cabana.
Yeah.
And I defaulted to dark mode because I stare at the damn thing every day.
Yeah. I like that.
Okay. So let's see. Oh, and then whatever filters you apply, there's a handy URL shortening link. So if you're collaborating over Slack or what have you, right? So that's a quick link you can fire to your coworker, and they're both looking at the same insight that you've arrived to.
Is all this information exportable? I'm assuming it is for
Absolutely.
reporting on.
Yeah, yeah. Every one of these are individually exportable. There's a reporting facility that we're bringing online in 6 months, so any of the screenshots can be taken of any of these dashboards. Yeah. So the next thing I want to show is a segue into the packet recorder. So over here we have the flows dashboard, and really that's generically named and turned out to be fortuitous because VPC flow logs can go in here, right? So this is a dashboard over our flow DB essentially. So what I'm gonna do.
So this collector can take not only our generated flow records, but third party. So if some other production device is generating NetFlow or SFlow, we can even consume that. So it's not just our generated records that we consume. We also consume the.
Yeah, we're seeing containers use flow records. So
Yes.
now we're seeing, with eBPF, we're now able to eject flow records from Kubernetes hosts.
Yes, yes.
Right?
So-
It's becoming.
Yes. So from the host, we can just take it over here. And this could be a centralized portion where all the flow records are coming and
Right.
one point to analyze all.
So I
across-
don't have bunches of flow detectors, or I don't. More importantly, one of the bigger problems with flow is if you have different flow collectors, sometimes you have to take a flow, duplicate it, and send it to 3 or 4 different destinations.
Yes.
And that is really excruciating because you spend a lot of time troubleshooting that.
Yeah. And even the use case that you mentioned, you can see, okay, what are the flow records generated by the Kubernetes host? Did it see it on the wire? If you don't see those flows on the wire, maybe somewhere else it got dropped. So you can do hop by hop debugging.
I can get it closer to the edge.
Yes, you can get closer to the edges.
So how quick does it return the analytics?
Sorry,
How quickly does it return the analytics? So are you getting near real time?
real time. It's real time.
It's near real time. Yeah, it's not real time. We're doing a lot in user space, so we're working modern data pipelines where we're pulling in a whole bunch of, so it's Kafka style, we're pulling together a bunch of information. And that does take some time to process. But the good news is this is a scalar architecture, so as load increases, we scale out with that.
But we are talking few seconds. Right?
Yep.
Yeah.
The value you're bringing to this is the networking focus.
Yeah.
Right, you're presenting the dashboards in a networking focus based on the data that we've collected with the Big Mon fabric.
Yes.
So we're unifying the two together.
Yes. And this could be
The value is not in the analytics platform per se, it's the integration with the other parts of the
Yes.
tool.
Okay. So I tried to find some computer that I recognize, but I'm not able to find that now. So I'm just going to go with 10.100.12.68. I don't know who that is. We're going to be
Greg.
seeing his packets.
It's me.
Wasn't me. You can't prove it, and it's not my fault.
So you see that the source IP selection carried on in here into the destination field. So the plus is giving you a hint that they can, more CIDRs, more IP addresses. You can hit a submit for this. Oops. So this had no packets somehow.
go to someone which has packets.
Okay, I'm going to select. So this is a Google address that I recognize, and the reason I'm going to go to Google is just to get a variety of traffic that we can report on. Let's select 86. I relaxed that source IP filter just because I wanted to get more packets in my dragnet. That's strange.
You want to go back to
So let's try that again.
just go there.
Okay. So that's going to be. So what I'm afraid of is going to be a whole ton of packets coming
You just
back.
Go select one of them.
Maybe take away.
Yeah.
Submit.
Yeah.
Oh, I don't know what's going on.
You want to select the other one?
You got a couple too many queries.
Yeah.
This is not going the way I
Yeah.
was expecting it. So let me go back to this other host. So we've got two offices now, and we've got packet recorders running at two different offices. 10, 4, 100, 4, 117.
If someone had 3 data centers, would it be smart to have packet recorders at each location?
It really depends. You can have, if there are 3 big enough data centers. So we have seen multiple deployments where either they centralize the packet recorders in one of the main data centers, or we have also seen a deployment where they scale it out, like they put it in every data center and then use the controller will fetch, send the query and get it over there. So you may have these BMF per data center deployment, the whole deployment, or you may kind of make it at central point. So we have seen both.
With a centralized deployment, how is the information reduced? All that net flow, you don't want that going across your WAN. So I know you
Yes.
said
So you
reduce that at the source location.
Yeah.
Is that something that's built into the product to be able to do that?
You can select on how much net flow you want to generate, what net flows, what subnets you want to generate the net flows for. It's not generated for all the net flows. So you can do pretty much a lot of filtering before you generate the net flows, and then you can use that.
And the sensors are installed on the host as well.
Yes.
So you have the host plus the network sensors.
Yeah.
Yes. So you can.
Everybody has to go that way, right? There's only 3 ways you can collect it. You either get flow records out of the network somehow, and the question is where do those flow records? You would put an agent into the VM or on the bare metal. So you put it in the NOS or on the vSwitch.
Yeah.
And then you capture the flow records out of that, or you put something in line, you put a proxy in line and get it to
Right.
eject flow records. There's no other way,
Yeah.
right? Or you get the app, you go in and reprogram the app to actually generate its own flow of records, some sort of structured log data that you can forward into the system. And all of these systems rely on the same principle of capturing those flow records. The question is, you have to design that. So in this case, I think the value here is they've got the big modern fabric, so that'll help you to capture the records from wherever the source, if it's a physical network tap, and if you're using big switch fabric, then you can actually use the VPC functionality to just say, give me flow records for everything that's in this group of hosts. So it comes down to how you design your flow generation, then how do you capture it, where do you direct that to, and then this is the back end, this is the water closet, if you like, where all the analytics, then all the data gets stored and then analysed. So it's always going to, any fabric, visibility fabric solution is always a combination of the parts. Right. And you choose which area you wish to focus on when you architect the solution. And it comes down to how dumb's the customer, how smart's the customer, what is it they think they want, what do they really want, how much money do they have, all that sort of stuff. It really comes down to how much visibility they want, how much data can they afford to keep, and how much data can they afford to analyze.
So I'm going to just segue away from here while we figure out what's going on. This is a different dashboard that I thought was very interesting because it correlates the physical and the logical domain. So right across the top here, you see are the 5 busiest filter ports. Right? So as you're scanning through this, you might see that this peak is of interest. Right? So you can click through there. Let me relax the time filter. And then what I have presented below for me here are the flows that actually accounted for that peak. Right? So you can see over here there's a HTTP flow, and then there's an NFS flow. Right? So we can see the NFS flow going on for those time units. And then at the same time these large flows were seen in the system, we have these smaller flows that could have been potentially impacted. So I think at this point, if they need questions, I'll take them. Else, we'll tee up the next person.
I have a question. Mm-hmm. How is this licensed? Is it per host? Is it per workload?
I'll let Prashant take this one.
Okay.
It is on a per switch basis. So there's a physical fabric, so it's on a per switch basis, and then each appliance is on a per appliance basis, whether it's ISO or some customers don't want to manage the server, so that's why we also, provide hardware appliances. And then when it goes to the host, then it is, per host license. So that's, it's essentially what is the underlying substrate on which it's deployed. So when it is in cloud, it'll be kind of, VPC based.
I think if some of what you're asking is, hey, do we try to charge by volume of traffic or by volume of stored analytics? We've avoided that because I guess we're really big believers that when you have this analytics, you really want more of it. And if we make pricing an impediment to people using more of it, then we're kind of steering the industry in the wrong direction.
Yeah.
If we can make it really actually inexpensive when you use more, that's better.
So in the case where you have a VM that has multiple containers within it, are those all considered host for licensing, or is it just per VM?
The license for us is per switch and per appliance. So you could have 1,000 VMs, you could have 10,000 VMs. No difference in
there's
pricing.
no per host licensing.
This is when we are in the host. So
I think this is when we're monitoring the host.
When we are monitoring the host, right? So if we are outside the host, if there is no presence in the host, then of course there is no limit to the VMs. I mean, whatever the switch traffic, switch captures the traffic, it'll capture all the endpoints. But when we are present in the host, it is not per VM based or per container based. It is per host based.
Okay.
And also on the service nodes, we don't charge separately for services. So you get dedupe, netflow, generation, header stripping, all of that. You can turn on any service on any port on the service node. So there's no additional license for that.
Thanks.
So I just got the explanation for why my queries are coming back 0. It's NTP problems. We got a marketing laptop out of hibernation. I don't know what year it thought it was in.
Times were off, so we have it now. Yeah.
Okay.
So back again, hope that's clear. So 114 megabytes, right? That was the summary query. Next, I can show you get details. And what this does is actually runs DPI in the packet recorder, right? The remarkable thing here is you're not decrypting any of the packets, but we have visibility into HTTPS, right? So you see Facebook, Twitter, SSL, eBay, right? SIP, YouTube, Apple iCloud, Quick, the UDP HTTP that happens with Chrome browsers, Slack. It's a good selection. We can actually retrieve for the packets. So that's that selection of the packet and submit. So now, packet recorder is a scale-out system. So what you just saw happen there was the query fanned out to a bunch of these busy buzzing packet recorders, and the controller gave us a coalesce URL, right? So that's that coalesce URL. That's a handy download into Wireshark, right? A lot of people don't. Oh, okay. I can talk about replay. So this is a really powerful feature of BMF. These same packets, traditionally you might have 10 expensive specialized tools maybe in the environment, but under SDN control, you could have one of those be placed at a central place, right? And through the replay, through packet replay, we can actually select a delivery port that the tool is hanging off of and have these packets be replayed there, right? So that's really cool.
So it can get the packet replayed to a Wireshark.
Yeah.
And then or my favorite tool.
Or like my IDS, right? So I could, if I find that I had an event, but my IDS didn't detect it because I didn't have it spanned at the time, I can go find those packets, play them back into my IDS and say,
if it triggers.
yeah, do I need to now go tweak my rules to find these types of events?
I think the thing that I'm getting at all of this is we're actually seeing the end of hardware-defined networking, right? Because this is really like Big Switch, and there's two companies that have been focusing on hardware-defined networking, where I use the hardware in the switch to accelerate my software functionality. I unify the software-defined functionalities with the hardware, and I get them very close together, and I get efficiencies or synergies out of that. But what you've talked about here today is really the end of the switch, logically. I mean, it's still there. It's still doing its thing. It's a useful tool, but it's...
You mean it's no longer about just passing packets?
I think it is just about passing packets, in the sense that I don't need to have S-flow coming out of the switch when I capture it from a VPC type model, and I don't actually care about span ports or getting a net flow records from an ASIC. As long as it just happens, I don't want to know anymore. I just want to go home. Honestly. I just remember the times I spent sitting in an office at 8 o'clock at night working on pointless activities on a switch. I just want to go home, And so I'm happy to see the end of hardware-defined networking.